in last conference, not last, but previous our conference, I was working in another project, but from that project, this new project became possible. And yes, here are details. And that is Latvian Research Council project. And the name is Laser Photo Detachment Spectroscopy on Negative Ions. And we are now approximately on middle of project. So I will tell how what status is and what results we would have. So we don't have a lot of, okay. We 100,000 euros in 1 year, that's not much, but I was very lucky to attract good people like previous speaker Jānis Salmis. Okay, you know his merits. And I would like to say one thing more. You made your postdoc at Hanš, but you got your PhD a lot of working in Lund. And I think you got a recommendation from Sune Svanberg for going to Hanš. Yeah, we had a young PhD student, Jānis Ničers, who was working in in Photonika for another experiment, another project. But when that project was finished, I was lucky to get him for my project. He is now PhD postdoc in Dag Hanstorp's lab. So PhD candidate Artur Civiņš, who is very close to finish his PhD studies with thesis. Then we have very good third-year students, Kalvis Kalniņš and Matīs Čakš, who doing their bachelor work now. And lucky we have one first-year student who will get knowledge from older students. So we have very good age and knowledge separation in our team. So we are focused on collaboration with universities of Gothenburg, Stockholm, and Malmö, as well as with CERN. And so since we are not paid very much and don't use full time for this project, we do another activities like Jānis Salmis in another projects and teaching. So why negative ions? Because negative ions is very unique atomic system. They are not attracted. Outermost electron is not attracted with Coulomb force, but with dipole interaction. And so for optical ions, optical transitions inside ions are allowed only for few of them. And so we rarely in our studies do photodetachment process, spectroscopy. And of course, here is some historical background that as a postdoc in 1990, I went to Gothenburg University and met Dag Hanstorp. Then I went to Lund University, met Sune Svanberg, and we started very fruitful collaboration. And I really was involved of the field of negative ions. And what is next slide? I have to look. Now, okay, I go back a little bit, and then I actually left academia since I got highest degree possible at university education, but it was very difficult to find good position at university system. So I switched to industry. And I went to my company, Micronic Laser Systems in Sweden, and I spent 18 years in that company. And now I return back to academia. Well, what is actually a very rare case, because it is very difficult transfer from company back to university. So, and therefore for me was easier to find field where I have been working and renovate old contacts. Yeah, so it is. So about negative ions, here you see for those, okay, over periodical table, you have three colors: blue, dark gray, and light gray. And for blue elements exist negative, stable negative ions. And the height of column indicates what electron attaching energy have negative ions. We see that I think fluorine has highest attaching energy. What to detach it, you need blue light, what is quite a lot of energy. And for some elements, this energy is very, very little. For example, for calcium negative ion. And then we see that here is very interesting that for a lot of ions, we have this dark gray region. There, those are ions for whom we don't know. Does exist negative ion or not? So not theoretical prediction, not experimental observations. So, and one of the tasks of our project was to check if gadolinium, who is in table between two ions for whom we know they exist, that maybe we could build some systems that we can observe them. So photodetachment works. In principle, you cross ion beam with laser beam, and you can detect or neutral particles, neutral atoms, or electrons. if you do it in cross beams, usually you detect electrons what are perpendicular to both cross beams. But their interaction region is very, very small. So we developed in Göteborg in photo detachment technology in merge beams. There we have much larger interaction region, but emission of electrons are in very large region. So it's very difficult to detect, but we can detect ions. Oh, I think I have to use this. So this is done in ring. We have deflectors, beams come, ion beam coming in is deflected, and then it's deflected out. But detached atoms, which we get from detachment process, they continue here in straight way. Then was developed neutral particle, neutral atom detector, which hits plate, then electrons are hitted out from this and collected out from this region and detected by channel electron multiplier. So we get much larger efficiency in this process. And a lot of studies, negative ions can be done by using this ring, ion ring Desiree, about what Richard will tell in some of next talks. So how photo detachment cross-section works, that if we go scan laser beam, so at some moment, okay, we don't have energy enough for hitting out electrons. But then at some moment here is photo detachment cross-section. Photo detachment process starts to work, and there is threshold phenomena, and we can measure with quite high accuracy this photo detachment threshold, and those are results from other setup from for the trap in CERN. And yeah, so for the first year, I have promised that we will have one publication in our project in a good journal. So we have done it, and we have two manuscripts which are very close to send out. Really, final discussions before co-authors are going on, and yeah, and then we have more results which are not experiments on negative ions, but where our project people were involved, and they were supported by our project. Yeah, then it's work on thesis. And conclusion from this, what I can say after 1.5 work in this way, because it seems to be simple. You're just sitting at home, preparing you for experiment, then you go abroad, and then you get results and get publication. But it's not so simple, because it is very important that all members of project team, they can go to site when you get beam time. For example, for CERN is very difficult part, that you can get user status. And that starts to be expensive because you need time to get, you have to be in CERN and you have be there and spend longer time than your team is doing experiment just to get permission to go into experimental area. No, and one thing more is that not every mission is successful, because one has to work, or all team has to work very hard, very short time, 1 week for experiments. If you don't get the signals and results within 1 week, okay, wait until next mission. And you never know when you get it. So just for writing such a project, one have to plan much more expenses for trips to go to sites, or to find out another source of support. I see more complicated part is preparation for publications, because you are many people in team, and writing publication is very hard work if you want to get a good publication in good journal. And then it is no one really wants to do it. And of course the problem is that we have to do some preparation of work, preparation work for this. And then if we need to buy some things for our setup, what we have downstairs here, in first floor, then it becomes very difficult to find or to get this particle or this part for setup of another thing, that because it's very complicated procedure to purchase things. And acknowledgement is to all mentioned team members, to our collaboration partners, and especially Doug Hanstorp, who was really involving me in collaboration projects in CERN and in Stockholm. And then thanks for people who just helped us, especially for Arnold, for just working with students, supporting students, teaching them. Alexander Kapralos, who is glassblower, who made cells for calibration cells for photo detachment experiments. Dina, who supports me in any way when I get problems. And Inga Shirante for fixing this funding problems, because I did last year 1.5 year traveling money. And to Rashid Ganeev and Vyacheslav for teaching one of students, Kalvis, who is third-year student, and he already has half of publications for his PhD thesis.